On some planets, storms are impossible. Superheated Mercury is too small and too close to our sun to have a significant atmosphere. And no atmosphere means no storms. But move out away from the sun, and we find worlds with turbulent, chaotic atmospheres. They can spawn some of the most awe-inspiring megastorms in our solar system. This is Venus, a planet completely shrouded with clouds. Winds rip around the upper atmosphere at over 300 miles per hour.
About 35 miles above the surface, the winds are whipping around in a ferocious pattern that basically carries the cloud features around the entire planet every 4 days.
Venus is closer to the sun than Earth, and it's heat from the sun that drives the wind.
The circulation pattern of Venus's clouds is actually quite simple. There's a warm side of Venus and a cold side. And as air warms up and rises on the day side of Venus, it spreads around to the night side. So there's this continuous current. It's actually quite a lot simpler than the atmospheric circulation on Earth.
Venus's winds circulate faster than the fastest hurricane on Earth. But they look very similar. The Venus Express probe captured these remarkable images of the planet's south pole.
One of the great mysteries of Venus, which actually had jaws dropping in the halls of many astronomy departments, is the fact that we have hurricanes at the poles of Venus, especially in the southern hemisphere, that have two eyes. Not one eye, but two eyes. Now, we've never seen this before on such a planetary scale.
Venus's double-eyed vortex is 1,800 miles wide. Two hurricanes whirl around each other.
If you could descend into the vortex of Venus, something I would love to do, at least with a remote machine, I think you would see some kind of a fantastic wall of cloud and this sort of twisting form spinning around you at ferocious speeds. It would be quite a sight.
It's a mystery how deep this raging, spinning vortex goes. But maybe this megastorm eye descends to the planet's surface. Down here, permanent twilight bathes a volcanic landscape, and the atmosphere's colossal weight creates immense pressure.
And the atmospheric pressure on Venus is about 100 times that of the Earth. Think of taking a car, squeezing it down to about a square inch, and putting it on every square inch of your skin. You would be flattened within a fraction of a second because of all that pressure.
Venus's dense atmosphere creates one of the strangest megastorms imaginable. 4 miles per hour winds with the force of a hurricane.
The winds on the surface of Venus are actually very slow because Venus has a very slow rotation rate. It takes Venus about 8 months to turn once around with respect to the sun.
The crushing atmospheric pressure rams gas molecules together so tightly that they feel more like a liquid. A gentle 4-mile-an-hour breeze packs a brutal punch. It's like a hurricane in slow motion.
Winds on Venus are totally unlike anything we see on the planet Earth. You would almost feel like a molasses effect. It'd be quite difficult to simply walk and run right through the wind.
Venus's surface is so hostile that life is impossible here. the upper atmosphere's faster winds hold an extraordinary possibility.
Well, I harbor this, I don't know if I would call it a hypothesis or a scientific fantasy, but I do think it's plausible that there could be some kind of life living in the clouds of Venus. There are certainly energy sources. There's sunlight, and there are certainly nutrients. There's carbon, there's hydrogen, there's oxygen. All the stuff we think of that you need to make life exists in the clouds of Venus.
Earth's upper atmosphere is full of life. Microscopic bacteria drifting on the wind. Could Venus be the same? Perhaps one day we'll send a probe to find out. Leave Venus behind, and the next planet is Earth. Here, too, the weather gets extreme. We are bombarded by tornadoes, hurricanes, and these dust storms. On Earth, they're localized. But on the next planet out, they engulf an entire world. Over 100 years ago, astronomers thought they had found life on Mars. A dark wave spread from the pole towards the equator. They thought it was springtime vegetation spreading across the planet. They were right about the season.
Mars tilts at roughly 23 degrees like the Earth, so you would have summer, fall, winter, spring like the seasons.
Seasons bring weather. The shadow astronomers saw was actually dark rock uncovered by a violent dust storm. It's all because of the way the planet tilts. The Earth takes 1 year to orbit the Sun. In January, the northern hemisphere leans away from the Sun, and we get our winter. In June, it leans inwards, our summer.
Mars has gigantic planetary dust storms, the like of which we've never seen here on the planet Earth.
Mars has around the same tilt as Earth, and springtime means storms. The Martian surface vanishes under a cloud of raging dust particles. On Earth, we get dust storms too. They can be devastating, swallowing entire cities. July 5th, 2011, Arizona. An unstoppable 5,000-foot-high wall of dust smashes into Phoenix. Day turns to night. Thousands of tons of dust settle over the city. But the disaster stays in one place. Mars's dust storms can engulf the entire planet.
On Mars, when dust gets kicked up once, it lands, it can get kicked up again and again. The dust is reusable. On the Earth, when dust gets kicked up and then finally settles out, it's probably going to settle out into the ocean, where it's gone for good.
There's nowhere on Mars where there isn't ready dust and sand to add to that storm. So these storm systems can kick up and last weeks or even months.
Mars's incredibly dry atmosphere contributes to the storm's size and power.
In the case of the Earth, dust that gets up into the atmosphere is rapidly washed out by the rain and gets into the ocean. In the case of Mars, there's no comparable rain to wash the dust out. So once the dust gets into the atmosphere, it just sits there until the particles by themselves are able to slowly settle out.
A lack of rain allows Mars's dust storms to cover the planet. But dust storms on Mars can be equally spectacular on a much smaller scale. NASA rovers captured these extraordinary images. Dust devils sucking up fine, dry iron oxide dust. The biggest dust devils can reach 6 miles into the sky. They pump fine particles high into Mars's atmosphere, creating a haze of dust that may help control the planet's dry climate and lead to a planet-wide megastorm. Even on Mars, dust storms this big are rare. Astronomers have detected just 10 in the last 100 years. What the ancient astronomers mistook for life was a megastorm. But even a planet-covering dust storm is dwarfed by the weather on the next planet out from our sun. This is the giant of our solar system, Jupiter. Jupiter is gigantic. It's 2.5 times more massive than all the other planets in the solar system added together. It's also home to gigantic megastorms. Jupiter's high-speed rotation drives vast bands of counter-rotating clouds. Colossal storms build along the boundaries. And this is the biggest of them all. The oldest storm in the solar system. 15,000 miles across and over 300 years old. The Great Red Spot. Around the edges, turbulent winds rage at over 300 miles per hour.
The Great Red Spot is a giant vortex, meaning that in the case of the red spot, it has a high pressure center with winds that swirl around the outer edge. So in that sense, the Great Red Spot is a little bit like a hurricane.
A hurricane with a difference. On Earth, hurricanes feed off heat from the ocean. When they hit land, they start to die. So on average, they last only about a week.
Jupiter does not have land. Jupiter is a completely gaseous planet, and the friction there is very weak. And so a vortex, like the Great Red Spot, can last indefinitely. There's nothing to slow it down.
To keep going, all the red spot needs is a power source. On Earth, ultimately, that's heat from the sun. But Jupiter's 5 times farther from the sun than us. Heat from the sun is not enough to drive the red spot. Instead, Jupiter has an internal power source, its own immense gravity. In 1995, NASA launched a probe straight toward the giant planet's heart. It plunged into Jupiter's upper atmosphere at over 106,000 miles per hour. As it fell, the planet's crushing gravity ratcheted up the pressure. 10, 15, 20 times what we feel on Earth. winds gusted to over 400 miles per hour. The probe gave out just 100 miles in, crushed by pressure and fried by the incredible heat the pressure generated. Had the probe made it deeper, it would have reached a vast silvery ocean. Intense pressures here turn hydrogen gas into a churning metallic liquid, superheated to over 40,000 degrees Fahrenheit. Jupiter's interior pumps out about twice as much energy as the surface gets from the sun. This is Jupiter's power source, the heat that drives its massive megastorms.
All of the convection, all of the heat comes from the hot, dense interior of the planet itself. So the bands of clouds that you see that are even counter-rotating, going in different directions, those are all driven by the internal heat of Jupiter itself.
Jupiter's internal heat drives its violent megastorms. But the giant planet may hold clues to an even deeper mystery. Could life exist on other worlds? NASA's Cassini probe studied Jupiter as it flew past en route to Saturn. It made an extraordinary discovery. Strange white clouds just north of the Great Red Spot. Clouds just like the clouds on Earth. Droplets of liquid water. Could Jupiter have the ingredients for life?
The question of life on the giant planets is an interesting one. You have many of the ingredients for life. You have sunlight coming in, there's liquid water, at least in the form of cloud droplets. On the other hand, if life can easily exist in clouds, you might expect that bacteria and algae would populate the clouds on Earth and the clouds would be green. We don't see that on the Earth. We do see microbes at many altitudes throughout the Earth's atmosphere, but they seem to largely be blown off of the surface.
It's likely that life on Earth began on a solid surface. But could life evolve without one?
There's no surface on Jupiter, and so that makes it difficult for organisms to have a constant source of water. So if you imagine yourself being a little bacterium inside a cloud droplet, you're going to be in deep trouble when that cloud droplet evaporates.
Whether life exists in Jupiter's clouds or not, gas giants like Jupiter and its neighbor Saturn have all the right ingredients. Water, heat, and one other vital element, a spark. Lightning on an unimaginable scale. These haunting images are from NASA's Cassini probe. Its mission, to explore one of the solar system's most awe-inspiring planets, Saturn. The probe reveals Saturn's rings, moons, and the planet itself in near perfect detail. Chaotic bands of cloud race around Saturn at more than 1,000 miles per hour. Finding storms here was no surprise. It's a planet of storms. But this was astonishing. A bolt of lightning, a gigantic thunderstorm on an alien world. Lightning creates some of the most spectacular weather on Earth. Electrical tension builds between the top and bottom of a vast 55,000 feet high storm cloud. A maelstrom of water vapor, rain, and ice. Tiny ice crystals drive up past hailstones falling down. As they rub past each other, it builds up a charge. When the strain gets too great, you get an electric spark. On Earth, the average lightning storm stretches 15 miles. On Saturn, they can reach around the whole planet.
There are examples of lightning storms on Jupiter and Saturn where the anvil cloud, in other words, the big cloud at the top of the storm, starts small and grows to be 20,000 kilometers long. That's the size of the Earth.
On Saturn, we registered one lightning storm that was 10,000 times greater than any lightning storm found on the planet Earth.
Lightning is hotter than the surface of the sun. The atmosphere literally explodes. The sound we call thunder. On Earth, it's the sound of new life.
Lightning seems scary and destructive, but actually it's very productive for life on Earth. And the reason why is because of its influence on atmospheric chemistry.
Every bolt literally burns the air.
When you have a lightning discharge, you get this very high temperature, very energetic plasma, and that breaks up the nitrogen molecules in the atmosphere, frees up those nitrogen atoms to enter into other kinds of molecules, and those nitrates formed by lightning allow nitrogen to go into the soil as basically fertilizer, enter into plants, enter into the life cycle. So it's the lightning that frees up nitrogen atoms in the service of life on Earth.
Earth experiences 8 million lightning bolts every day, helping life evolve and colonize the planet. But for Saturn, lightning alone may not be enough. There's nowhere for alien life to live. One place in our solar system may solve that problem. Saturn's moon, Titan. It has an atmosphere. It has lakes of liquid methane. And its own bizarre brand of megastorm. Saturn is almost 900 million miles from the Sun. This far out, orbiting the Sun takes time. Saturn's year is nearly 30 Earth years long. Right now it's spring, and things are heating up.
Moving into the summer cycle of Saturn. So the atmosphere is slightly heating up, even as distant as Saturn is from the Sun. We've got a little more energy, and we're seeing the most spectacular storms we've ever observed on Saturn.
After years of frozen silence, Saturn is coming alive. Scientists have waited nearly 15 years for the Sun to light up its North Pole, to reveal extraordinary details about one of the strangest megastorms in the solar system. Saturn's unique hexagon storm.
A hexagonal pattern, how can that be? In Mother Nature, we have jagged objects. We don't have geometric figures arranged precisely, especially at a gigantic planetary scale. However, there's some theories. If I take a bucket of water or a bathtub and simply vibrate it, I get waves, waves that travel. But there's another kind of wave. You have traveling waves, but then you have stationary waves. Inside a bucket of water, you can get resonances. Water pulsates like this. And you can also get them to pulsate in a circle like this to create regular patterns. These are called stationary waves, and we think that this mysterious hexagonal pattern on Saturn is a hexagonal standing wave.
The megastorm at Saturn's North Pole is a wind that travels at hurricane speed, cornering sharply 6 times as it races round the planet. The central clearing is so big, you could fit 4 Earths inside. What lies beneath its surface is a mystery. As Saturn warms from spring to summer, another world comes alive too. One of Saturn's moons, Titan, is warming up. And with the warmth come the storms.
One of the most interesting moons in our solar system is Titan. It's straight out of science fiction. It's an object with yellow skies and methane clouds that is truly remarkable.
NASA's Cassini probe reveals Titan in unprecedented detail. A thick, dense atmosphere, vast mountain ranges, lakes of liquid methane, and this, an arrow-shaped band of white methane clouds moving over its surface. When the clouds drifted over a dusty open plain, seen here as a dark patch, the dark patch of ground beneath the clouds grew larger. Scientists believe liquid methane drenched the surface. A spring rain storm, Titan style.
Rain on Titan, if it exists, would be very different from rain on the planet Earth. First of all, the gravitational field is very weak, so you would actually see raindrops falling very slowly at you. Also, the size of these droplets could be much larger. But don't get caught in a rainstorm on Titan. Those droplets are awfully cold.
Titan's methane monsoon sweeps across the moon. Weak gravity creates ultra-cold, hazelnut-sized raindrops, an alien world with truly alien weather. These slow drops have carved valleys and lakes, much like ours on Earth. A slow-motion megastorm. But fly even farther out through the solar system, and you find storms that are altogether faster. This is super-chilled Neptune. The temperature never gets above 300 degrees below zero.
Neptune is one of these giant planets. It's much larger than the Earth and has a very thick atmosphere. It's about 2 billion miles out from the sun. So you really might expect, since it's that far from the sun, it would be very cold and not have very much weather. But in fact, Neptune is very dynamic. It's got tremendous weather patterns.
Despite its incredible distance from Earth, astronomers can get close to Neptune's turbulent atmosphere. With a little help from this. The Keck Observatory, 14,000 feet up on the summit of Mauna Kea in Hawaii. It sits above Earth's clouds and pollution. The telescopes are so powerful, they could see a candle on the moon. Neptune at first appears featureless. But a closer look reveals white, high-altitude clouds in the upper atmosphere. It's a perfect opportunity to track wind speed. Measuring the time and distance the clouds take between 2 points allows scientists to clock their speed. The Keck telescope swings towards Neptune. A series of shots track the white clouds as they move around the planet.
So here we can take several photographs that show the positions of clouds apparently changing. You can measure the position at one moment to be there, and at another time, a few hours later, to be in a different place. Now, most of that change in position is due to the rotation of the planet as a whole. However, if you know the rotation rate and subtract that out, that gives you the motion of the clouds relative to the planet. That tells you the wind speed.
The results are shocking.
We're seeing wind speeds on Neptune of many hundreds of miles per hour, up to 12 or even 1,260 miles per hour for the very fastest clouds. That's really phenomenal.
Neptune has the fastest winds in the solar system.
So what's driving this? You need energy to make weather. Where's that energy coming from? And it turns out it's coming from Neptune itself. It does receive sunlight, but Neptune actually radiates away more energy, a lot more energy than it gets from the sun, which means the interior is very hot. Probably it means there's radioactive material in there, there's leftover heat from when Neptune formed 4.5 billion years ago that's very slowly leaking out. And it's that that's heating up the air and driving all of the circulation and all of this crazy weather that Neptune has.
Neptune's storms hit hard. But the search for truly extreme weather takes us out of the solar system altogether, into uncharted territory. Out here, there are storms that make even Neptune's winds look like a breeze.
Katrina was just a sneeze compared to the winds we have on Osiris.
The search for megastorms leads to alien worlds whose violence defies imagination. Space is full of stars and planets where violence and chaos reign. Astronomers scour the skies for new worlds, and the king of the planet hunters is Professor Jeff Marcy. He scans the night sky seeking new worlds around distant stars. Marcy's team has instruments so sensitive they can even predict the weather on these distant planets. This is Osiris, 150 light years from Earth. A planet from hell with matching weather. Earth is 93 million miles from the sun. It orbits the sun in 1 year. But Osiris is just 4 million miles from its star. Its year races by in just 3.5 days. When Osiris passes between us and its star, starlight briefly shines through its atmosphere, giving us a glimpse of conditions on the alien world.
And they waited until the planet was in front of the star. At that moment, some of the starlight passed through the atmosphere of the planet. They were able to do essentially a chemical assay, a chemical assessment of the composition of this atmosphere.
Osiris gets blasted by the intense heat of its star. Temperatures top 2,000 degrees.
Now, what that means is that the environment on that planet is, well, hideous for life as we know it. But even more, the intense heat causes the gases to expand, and they have no place to go but the backside of the planet.
Osiris is tidally locked. The same side of the planet always faces the star. The other looks out into space. The temperature difference is immense. Superheated atmosphere roars from the bright side of the planet to the dark at nearly 6 times the speed of sound.
In fact, the winds will be something like 2,000 or 3,000 miles per hour. Enormous speeds of these winds, 10 times, 20 times faster wind speeds than the strongest hurricanes. Katrina was just a sneeze compared to the winds we have on Osiris.
Osiris is a brutal world. Too hot and too violent for any kind of life we could imagine. But there are even larger megastorms, storms on the scale of whole galaxies. And these vast storms may be the reason any of us are here. The Hubble Space Telescope captured this stunning image of the galaxy NGC 3079. At its center, a superwind, a storm on a truly cosmic scale. It was triggered by an explosion from a forming star. This raging galactic storm is about 3,000 light years wide. It has already raged for around 1 million years. Filaments of 20 million degree gas tower above the spiral galaxy. This cosmic megastorm wreaks havoc within its host galaxy.
We see bubbles and jets and formations of gas falling into the galaxy, colliding with galactic dust.
The gas from the galactic megastorm smashes into gas and dust at the heart of the galaxy and compresses it into a swirling mass of matter. Gravity takes over. The compressed clouds of gas and dust get tighter and tighter. The center gets hotter and hotter. Finally, it ignites. Powerful winds from the new star blast into space. The whole cycle begins over again, and a new galactic megastorm is born. Around the fledgling stars, dust and rock come together. The birth of new worlds with rocky surfaces where life could begin.
And perhaps the formation of life itself may be determined by how these gases swirl and create supergalactic storms. And if you have galactic winds churning away, then that would help to distribute the elements necessary for life throughout the galaxy. So galactic storms may in some sense be one clue to the formation of life itself.
Galactic megastorms rage for millions of years. Billions of years ago, they may have created new homes for life in our Milky Way galaxy. On every scale, storms are not just a force of destruction. They are linked to creation itself. The search for life on other worlds is also the search for storms.
When you disrupt the status quo, you open all kinds of possibilities for things to reassemble in different ways. So chaos or disruption is actually an important factor in the development of complex systems like life.
A planet that might have changes of seasons, volcanism, intense storms, some environmental factors that you might think could be damaging to life, in the long run makes life stronger.
The solar system, 8 planets circling a central star, our life-giving sun, once thought to be a place of order. But from time to time, the natural harmony of the heavens is disturbed when a strange light streaks across the skies, an evil star, a harbinger of doom, a comet. But the facts behind these erratic objects are far stranger than the fiction. Comets have been flying around our solar system since its creation, 4.6 billion years ago. They may have helped shape our planet's destiny. And incredibly, without them, we might not even be here.
Comets contain some of the most primitive material in the solar system. Material that has been there for 4.6 billion years. It captures a record of what the solar system was like.
Comets are important for helping us to understand our place in the universe.
Comets giveth and comets taketh away. They are both the creators and the destroyers of life.
That's an astonishing claim, but there's evidence that it could be true. One thing is certain. Any object 1 mile wide crashing into Earth at over 20,000 miles an hour is going to cause major problems. We only have to look at the dinosaurs to see the devastation a comet strike can cause. 180 million years ago, dinosaurs ruled the Earth. Their reign lasted for more than 140 million years, and then suddenly, they died out. Most scientists believe their extinction was the result of a major impact 65 million years ago. A 6-mile-wide comet, or asteroid, hit Earth at over 20,000 miles per hour. The initial impact had the force of 1 trillion tons of TNT. It killed everything within an area of 300 miles. Enormous tidal waves swept around the world. The impact triggered violent earthquakes and volcanic eruptions. Savage fires swept vast distances. 1 trillion tons of debris was thrown into the atmosphere, blocking out the sun. Earth's temperature plummeted. In the blight, large herbivores and carnivores died, followed by plankton and marine reptiles. The comet's impact was devastating. It's a process that intrigues planetary scientist Carrie Liss.
Dinosaurs were dominating the planet from 120 million years ago to 65 million years ago. To put that in context, we've only been as a hint of the human race for 3 million years. Without an impact 65 million years ago, reptiles would probably still be dominating the Earth, and mammals would be secondary or just small little creatures.
The death of the dinosaurs paved the way for mammals to flourish. They were highly adaptable and soon became the dominant force on Earth. There was a sudden evolutionary boom as whole new species emerged. One of these, eventually, was us. It's 65 million years since the last mass extinction impact. Scientists believe that one day, Earth will be struck again.
We don't have to worry about that tomorrow, but in the next million years. This sounds almost like science fiction, but we do need to worry about it as a species if we don't want to have the problem the dinosaurs did.
Luckily, we have an advantage the dinosaurs never had. We're smart enough to study our enemy and uncover scientific secrets that have lain hidden since the birth of our solar system. Today, we have the technology to send fleets of satellites out into deep space to intercept comets, smash into them, even to land on them. But some of the earliest and most revolutionary research into a comet was done using a simple wooden telescope. In the 17th century, a British astronomer, Edmund Halley, tracked the movement of these celestial bodies. He correctly calculated that a comet observed in 1682 traveled around the Sun in a highly elliptical orbit, returning every 76 years. Halley's research revolutionized comet science, but he still had no idea where these mysterious bodies came from. To understand this, we will travel back in time 4.6 billion years to the very birth of our solar system. We now think that in the beginning, the solar system was just a thick molecular cloud of dust, ice, and debris spinning in space. As it spins, it collapses to form the sun. The leftover particles stick together in clumps, which in turn form comets and asteroids. Over the next 100 million years, gravity causes many of these to come together. They grow to form over 100 protoplanets. Then the most violent stage begins. A fight for survival as whole worlds collide. At the end of the war, only 8 planets remain. One of them is the embryonic Earth. Any comets that don't merge into a planet are cast out by the gravitational force of the new planets to the very outskirts of our solar system. An area billions of miles from Earth. We can't see this region directly, but by studying the orbits of thousands of comets and recording how they enter and leave inner space from every direction, scientists think comets must come from an enormous spherical cloud completely surrounding our solar system. They call it the Oort cloud.
Our best understanding of the Oort cloud is that it contains about 1 million comets, and if you're standing on one comet, your nearest neighbor would be 10 to 100 million miles away.
It's a strange existence. These bodies have floated alone through outer space for 4 billion years in orbits so vast and slow that it takes them 30 million years to circle the sun. For this reason, scientists call them long-period comets. Out here, comets are as black as coal and nothing like the bright-tailed bodies we see from Earth. But occasionally, something happens that transforms their appearance for good. Comets in the Oort cloud are unstable. The pull of a passing star can upset their equilibrium and send them plunging toward the inner solar system, accelerating as they go. For centuries, man's observation of comets was confined to ground-based telescopes. But in 1985, that all changed. The European Space Agency launched the Giotto satellite. Giotto's mission was to fly 90 million miles into space and rendezvous with Halley's Comet. Scientists hoped to capture the first ever close-up color images of a comet, the nucleus rather than the tail, and unlock the secrets of its composition. Head of planetary missions at the European Space Agency is Gerhard Schwemm.
Giotto was really an exciting mission. It was also important for the European Space Agency. It was the first planetary mission, so to say. And it was really a risky mission because nobody knew about the environment of a nucleus. Would the spacecraft be destroyed?
In March 1986, Giotto flew by the nucleus at a distance of almost 400 miles, traveling at 150,000 miles an hour. Excitement grew in mission control as the first pictures of the nucleus streamed in.
It was elongated, about 10 miles long, 4 miles across, showed a lot of structure, and it also showed that the activity was really local.
This activity was gas and dust boiling off the surface of the comet. Giotto showed for the first time that gas production is confined to less than 10% of the total surface area. The rest is as black as coal. So what causes a comet to transform from an almost invisible lump into a whirling ball of bright white gas? The answer is our sun. As a comet moves closer to the sun, heat cracks the surface, and solid ice buried deep in the heart turns to gas in a process called sublimation. The cloud of gas, known as the coma, surrounds the comet. Then powerful solar winds blast the gas and dust into an enormous tail millions of miles long. There are so few particles in it that they could all easily fit into your average suitcase and still leave room for a change of clothes. The solar wind is so strong that no matter which way a comet is traveling, the tail always flows away from the sun.
These tails can be very, very long, longer than the distance between the Earth and the sun. So a comet can be, at the same time, a very small thing, one of the smallest bodies in the solar system, and at the very same time, also a very large thing.
Throughout human history, the appearance of a comet in our skies has struck terror. People have seen them as evil omens, the bringers of death. Man's fear of comets fascinates astronomer Don Yeomans.
The fear of comets probably came from the fact that, unlike the planets, comets would appear suddenly, they would look very different from anything else in the sky, and they would disappear.
This unpredictability has even caused war. In 1066, William the Conqueror saw the appearance of Halley's Comet as a sign from God to invade the British Isles. Even in modern times, comets have resulted in very bizarre behavior.
There was the incident back in March of 1997 when Hale-Bopp, a very bright comet, appeared in the sky, and this cult, the so-called Heaven's Gate cult, thought that a spaceship was following Hale-Bopp in the skies and was meant to receive their vessels or their bodies. So 39 of them took a cocktail of phenobarbital and vodka and killed themselves.
We'll never know if the cult members' bodies made it to the mother ship. They didn't leave a forwarding address. For most of us, science has dispelled the myths surrounding comets and replaced them with a new kind of wonder. Our technology is now so powerful that we can probe these ancient bodies and through them read the entire history of our solar system. What they tell us is how the Earth first came to be. Comets are the most distant bodies in our solar system, but astonishingly, their story sheds light on our own. Comets formed in the earliest days of the solar system. They carry vital clues to the origin of our planet. To unlock the secret of a comet's composition, scientists analyze them with a spectroscope. A spectroscope works by breaking down the light given off by an object into its constituent colors. Each color is unique to a particular element. By analyzing these colors, scientists are able to infer that a comet is a dark organic compound of carbon, hydrogen, minerals, and most importantly, about 50% ice water. A dirty snowball. Now we know the recipe. Carrie Liss can build one in the lab.
These ingredients are clearly something very common found on the Earth, and yet we see them also in comets, and that's not surprising because comets made up the material that we see on Earth. So we're going to start with dry ice, which is solid carbon dioxide. This is dirt, representing the rock-forming elements we see in comets. This is water, which is about half of all the material in comets. And window cleaner, which has methanol and ammonia in it, minor icy species that we find in comets, but important ones. And finally, chocolate sauce. Chocolate is not found in comets, but it represents the complex organics. We see all kinds of amorphous carbon and PAHs and tardium-like materials. And our chocolate sauce is going to represent that because it's easy to work with. Just we'll start with the dry ice. Okay, put that in here. Dry ice is the same stuff that is used in movies in order to make fog, and you're going to see some of that come off. Oof, it's cold. Next, we're going to put in our rock-forming elements, represented by our dirt, and we're going to put a good fraction of them, because they're about half of all the material we see in comets. Next, we're going to put in our complex organics, and we're going to put in a dash of them, because they're only about 5 or 10%. window cleaner. And finally, we're going to put in our water, which is the majority component, about a third to a half of all the material in comets.
With all the ingredients combined, Liss gives gravity a hand and packs them together.
Okay. What you see here is a comet. You can see it's smoking, or what looks like smoking. That's actually the carbon dioxide subliming. There's a little gas jet right there, and comets do that as well. And this is very much what we think is happening on comets. And it's even got little patches of ice. It loses about 200 pounds a second, in fact, when it comes in and early around the sun. And a typical comet spends a few months near the sun. This is why they're still around after 4.5 billion years, after being formed in the early solar system. They just don't spend that much time bubbling and fizzing. Most of the time they're in deep freeze.
It's incredible to think that we can deduce the composition of bodies that are millions of miles away. But we also know that from time to time, comets come close to Earth, sometimes too close. In fact, in our planet's early history, it was bombarded by billions of tons of space debris, including comets. This is called the Late Heavy Bombardment. For 200 million years, billions of tons of comets and asteroids, traveling at over 23,000 miles an hour, crashed into the Earth. The planet was a scalding cauldron of molten rock. Temperatures were almost 2,000 degrees. No life could survive in such an inhospitable place. If a person were to step onto the surface, they would instantly roast alive.
The impacts of objects coming into the Earth made the surface so hot that life couldn't possibly form, and water wasn't resident on the surface either.
So there is a mystery. Some scientists believe life began immediately after this period. But you can't have life without water. So how did water arrive on arid Earth? The answer may lie with comets. In 1985, NASA discovered water for the first time inside a comet. Hal Weaver led the investigation.
Water is necessary for life as we know it. And we know for certain that comets are predominantly composed of water, plain old water, which is a life giver, and this is one of the main ingredients of a comet nucleus.
But why didn't all the water evaporate? There is one theory. As the heavy bombardment slowed down, the Earth's temperature dropped, and molten rock on the surface began to solidify. Any later comets impacting the Earth would have ejected their water into the atmosphere. Over time, this rained back down onto the cooling Earth. Eventually, pools of water developed on the surface. But some scientists argued that not enough comets could have left the Oort cloud and found their way to Earth to provide all our water. American astronomer Gerhard Kuiper theorized that there must be another source of comets in our solar system. The area was named the Kuiper Belt, and the hunt began. For over 40 years, scientists scoured space. Then in 1992, astronomers made an amazing discovery. Beyond Neptune, in an area thought to be empty, they found the first Kuiper Belt object.
The discovery of the Kuiper Belt revolutionized our view of the solar system. No longer did the solar system end at Neptune and Pluto, but there's a whole array, a whole new region that contains, hundreds of thousands of what we're calling icy dwarf objects.
These icy dwarf objects are comets, and they are billions of miles closer to the inner solar system than those in the Oort cloud. Scientists named them short-period comets and think there are as many as 100,000 in the Kuiper Belt. Some are as large as 600 miles across. That's bigger than New York City. Calculations show that the modern-day Kuiper Belt is a shadow of its former self. The number of objects originally present was 100 times larger than it is now. making it a likely source of water-carrying comets. What is astonishing is that Kuiper Belt comets are still delivering material to the Earth today. It's no longer a bombardment, but comet dust rains down on us all the time. And this dust is key to understanding how our whole solar system formed. As our planet moves around the solar system, we sweep through the particle tails of comets. The large chunks burn up on entry into our atmosphere. Some smaller pieces float to Earth intact as space dust. This dust is fascinating to science because it contains detailed information about how the Sun, the Earth, and all the planets in our solar system formed. But there is a problem. When comet dust comes into contact with the Earth's atmosphere, it changes chemically. The record of the early solar system is damaged. Scientists began to search for a way to collect uncontaminated samples directly from a comet. NASA's Stardust mission was born. One of the chief scientists behind the project was Mike Zelensky.
To actually be able to go to a known comet and grab a sample and bring it back to Earth and have it survive all those processes was just a fantastic prospect.
The Stardust satellite's target was Comet Wild 2, a Kuiper Belt comet over 3 miles wide and traveling at over 13,000 miles an hour. To harvest the speeding dust, NASA developed a glass aerogel to catch the particles without destroying them. They mounted the aerogel inside a matrix that extended from the satellite on a tennis racket-like paddle. The mission launched in February 1999.
The day of the launch, you're out there watching this rocket and hoping that it doesn't blow up, that it takes off on time, something doesn't go wrong at the last second.
We have main engine start, 0, and liftoff of the Stardust spacecraft, returning a time capsule with the elements of the formation of our solar system.
It's just so exciting to watch it finally go, and to know that, really it's out of your hands now.
Got solid motor jettison, all 4 solids came off.
Once in orbit, the satellite began its 3 billion-mile journey to the comet. To make the rendezvous, Stardust had to orbit the Sun 3 times, then slingshot past the Earth. After 30 years in development and 5 years in flight, the moment of truth arrived as Comet Wild 2 appeared in its sights. Tension in mission control was at an all-time high.
We didn't know how close to pass to the comet. You pass too close, and the grains are so large they destroy the spacecraft. If you travel too far away, you don't catch anything.
In January 2004, Stardust flew 150 miles behind the nucleus of Comet Wild 2. The paddle extended, and a steady stream of particles smashed into the aerogel collector. With its objective complete, Stardust began the long journey home. 2 years later, the capsule carrying the dust samples broke through the Earth's atmosphere.
It's 3 in the morning, it was a very, very cold night, and went outside and watched it re-enter. It was this huge fireball coming in.
17 degrees aft, rapid brightening.
Oh, that's cool.
NASA kept a very close eye on the capsule as it re-entered. They could not afford to lose it.
Quite a trail.
It was just tremendously exciting to watch that, to know that, there is our sample coming back, and we just go get it now, and it's ours forever.
With the capsule safely back in the lab, scientists slowly peeled the lid open. This was the moment of truth. Had the mission worked?
We looked at it, it was so clean looking, our first thought was, it didn't work. We're in trouble, we're screwed, this didn't work. And then only gradually we begin to see these impacts peppering the front of the aerogel and know that it did work.
Really unbelievable. It's amazing, amazing. Nice work.
At the Johnson Space Center, the job of analyzing the comet dust inside powerful electron microscopes began.
Everyone's fascinated by these crime TV shows where the scientists look carefully at tiny little clues, try to figure out who murdered this person. That's exactly what we're doing here. We're looking at tiny little clues very carefully with giant magnifying glasses, essentially, to understand exactly how the planets were born and how the sun was born and what was there before that. And just like being a detective.
Comet detective Zelensky and his team have found grains that have been superheated. They must have formed very close to the sun in the earliest days of our solar system, and then been pushed out to the farthest reaches of space.
Look at here, you can see the particle entered here and then crashed into here, basically expanded out, either exploded or expanded out. And grains are trapped all along this bulb surface, actually. It's incredibly exciting to be able to go into the lab and see in there, suspended in the air gel, grains that are 4.5 billion years old, and basically our distant ancestors.
The Stardust mission shows that comets aren't just remote objects hurtling through space. They are intimately bound up with Earth's own story. In fact, some scientists even argue that if it wasn't for comets, life on our planet might not exist. The Earth. It's unique in our solar system because it's covered with life. But where did the organic material that makes life possible originate? Scientists thought these vital chemicals formed in warm ponds on the planet's surface, or they were hurled out from hot springs on the seabed. But a growing band of researchers are looking at an altogether different source: space. In 2002, scientists discovered organics like simple sugars and traces of amino acids inside a molecular cloud in space. These clouds are where comets formed. Were the essential ingredients for life delivered to the Earth inside a comet? Chief planetary scientist at NASA is Mike Mumma.
The amazing thing about comets is that they could have delivered the basic chemicals necessary for the emergence of life, and they delivered them in kit form.
This is still a theory, but if a kit of organics arrived on the early Earth via a comet, then comets could have started life on Earth. One of the most important factors in the survival of these molecules is the angle the comet strikes Earth.
So if a comet comes in vertically, all of its energy is deposited quickly, and we can see this by just dropping a rock into the water. Clunk! Makes a nice big splash. The comet hits the surface at high velocity, and much of it is destroyed. But on the other hand, if the comet comes in at a shallow angle, it can actually skip in the atmosphere. And some of the energy will be deposited on each skip. And so it will slow down the comet, and more of it can then survive when the final body strikes the surface.
This photograph seems to back up Mumma's theory. Were these craters made by an object bouncing along the surface before finally coming to rest? Some scientists believe that only a small percentage of comets crashed into Earth at a shallow angle, but the bombardment was heavy enough to deliver a significant amount of organic material.
Every element in your body, carbon, nitrogen, oxygen, was formed inside a star. It later was ejected from the star, collected in an interstellar cloud, and ultimately entered into a comet. It was delivered to a growing planet in the form of water and organics, and played a role in the emergence of life. And that makes us a part of the comet, the cosmos in turn.
If the secrets of our solar system's formation and the story of the creation and evolution of life on Earth were locked inside the frozen heart of a comet, then scientists at NASA were about to find out. In 1999, NASA approved the most daring mission to a comet yet. This is the stuff of a Hollywood blockbuster. Its name, Deep Impact. The principal investigator on the mission was Micah Hearn.
Comets are a preserved record of what happened 4.5 billion years ago. Unfortunately, that record has been disturbed on the surface layers of comets, and you have to get down to the interior to understand what the data really are in the time capsule.
Deep Impact's target was Comet 9P Tempel 1, a short-period comet about 9 miles wide. The mission was to shoot a 1-ton copper probe from the spacecraft into the heart of the comet, producing a crater over 400 feet wide and 40 feet deep. Scientists hoped that the crater would reveal for the first time the pristine organic material buried deep inside the frozen nucleus of the comet.
Deep Impact hitting Comet 9P Tempel 1 was quite a feat of navigation. Not only did we have to get to the comet's orbit, we had to get to the comet's orbit when the comet was there. It's like somebody on one side of the Earth shooting a bullet, and somebody on the other side of the Earth also shooting a bullet and having them hit in the middle.
In January 2005, Deep Impact blasted off from Cape Canaveral. Scientists in Mission Control waited anxiously as Deep Impact approached the comet. On July 4th, 2005, the probe hit Tempel 1 at 23,000 miles an hour. The team erupted in celebration.
I was thrilled, I was scared. 6 years of my life, if it had for any reason gone wrong, but it worked just beautifully, everything was fine, and it's a crowning achievement. It really makes you feel wonderful.
The probe's onboard camera gave scientists a ringside view of the comet right up to the moment of impact. The blast threw thousands of tons of fine dust particles into the atmosphere, much more than anyone expected. The thick cloud of dust was a real problem. It totally obscured the crater, preventing them from seeing the pristine nucleus.
The biggest disappointment was that the material came out in such fine particles that we couldn't see through it. If the material had come out with a lot of big chunks, it would have been relatively transparent.
Despite this, Deep Impact did finally reveal the consistency of a comet.
If you were standing on this body, its gravity is so weak that you'd weigh about a gram. You could easily jump off it. You could walk into orbit off of this comet. And it is so weak that you could actually burrow into it and burrow through it. It's like the strength of lemon meringue.
Modern technology has revolutionized our understanding of comets. They are no longer mystical objects of fear. They are echoes of our solar system's earliest moments. But these objects are still active today. They may even hold the key to our future. Because comets are one of the very few things that could wipe human beings from the face of the Earth. Human beings are the most successful species on the planet, and some scientists argue we owe it all to the effects of comets striking the Earth. But what may have helped create life could also wipe it out completely. Every year, the threat appears to grow as more and more comets are observed in our inner solar system.
Eventually, something is going to hit the Earth. We don't know when or how big the object is going to be, but the energy dumped into these big explosive events could wipe out, hundreds of thousands of people.
In fact, if a comet just 1 mile wide struck Earth, it would trigger a global catastrophe. The comet would rip through our atmosphere in seconds and crash at over 100,000 miles an hour. The impact would kill millions of people. But the chain reaction of natural disasters that followed would be far more devastating. Earthquakes would tear through the planet. Monster tsunamis would strike deep inland. Fire would destroy whole cities. A huge cloud of dust would obscure the sun. Weeks after the impact, the death toll would reach hundreds of millions. With little clean water or food, and our electricity network crippled, the Earth would fall into a nuclear winter. In less than a year, much of the Earth's population would be wiped out. One day, this could become a reality. Luckily, Earth has a protector, Jupiter.
Jupiter is the king of the planets. It's 320 times more massive than the Earth, and so its gravity is one of the dominant forces that interacts with comets. Jupiter just basically can swallow them up, either capture them into orbit around itself or perturb their orbit so that they really don't come directly in towards the Earth.
In 1992, we got our first glimpse of Jupiter's awesome power as it tore a comet called Shoemaker-Levy 9 into 21 pieces.
They came in at roughly 35 miles per second. This is incredibly fast. They went plunging, drilling a hole into the atmosphere of Jupiter, and then exploding. And a whole bunch of material from Jupiter then went shooting out through that same tunnel that was drilled into Jupiter's atmosphere and rained back onto Jupiter, creating these huge impact scars the size of the Earth.
The real showstopper was a 2-mile-wide fragment that struck with the energy equivalent to 6 million megatons of TNT, around 600 times the world's entire nuclear arsenal.
Witnessing an event like this really made us understand how tenuous our existence is. If we get hit, it could really threaten life as we know it.
Impact events are now rare on Earth, but they do happen. This home movie, taken in the Rockies in 1972, shows a small object bouncing along on the Earth's atmosphere before shooting back into space. If it had broken through, it could have destroyed a city. This time, we were very lucky. But the people of Tunguska, Siberia, were not so lucky. At 7:17 on the morning of June 30th, 1908, a mysterious object exploded overhead. The Earth shook with the force of an explosion equivalent to 1,000 Hiroshima bombs. The blast destroyed over 60 million trees across an area 12 times larger than Washington, D.C. Scientists now believe the blast came from either a comet or asteroid exploding 3 miles above the ground. Amazingly, only a small number of people were killed.
If a Tunguska-like event happened over a large metropolitan area instead of in the middle of Siberia, it would have caused widespread devastation.
If Jupiter fails to protect us from an extinction-level comet, is there anything we can do to protect ourselves? Don Yeomans is the manager of NASA's Near-Earth Object Program, the front line of Earth's defense.
NASA has started a Near-Earth Object Program. They started it back in 1998 in an effort to discover and catalog and trace the motions of all the near-Earth objects that could cause global disasters should they hit.
5 observatories around the world and an army of astronomers search the skies 24 hours a day, hunting for comets and asteroids.
It's what we call a low probability, high consequence event. So while they don't happen very often, thank heavens, when they do happen, they're catastrophic. And so it makes sense to have some insurance against them.
To find them, astronomers take multiple photographs of space over a period of time. A computer then scans the images and identifies anything that moves against the background of stars. Once it finds a moving object, the team can calculate its orbit to see if it threatens Earth. If one of these bodies is on a collision course, there are a number of proposals to deal with it. One popular method is to destroy it with a massive nuclear weapon. But if this fails, it could have disastrous consequences.
If the debris is not completely pushed away from the Earth, not only do we have then the same amount of mass and energy falling on the Earth, but it's now radioactive in addition. So a very large nuclear explosion near one of these asteroids could conceivably make the problem worse, not better.
Another idea is to build a spacecraft that can intercept the comet and use powerful extendable arms to steer it into a safer orbit. Or we could attach solar sails to a comet and harness the power of the sun to gently pull it away from a collision course. In the desert of Arizona, Jay Milosh has an even more ingenious idea.
If we should find ourselves threatened by a comet, and if we know the orbit of the comet long enough ahead of time, all it takes is just a gentle push to keep it from colliding with the Earth. I'm going to demonstrate how this might be done on this object, a potato, that is about the same shape as Comet Tempel 1 or Borrelli. And I'm going to use a solar collector, this hand lens, to concentrate the desert sun onto the surface of this. In reality, we wouldn't use a lens, we'd use a mirror, but this will work out here in the desert. As I concentrate the sunlight onto my model comet, you can see that we evaporate material from the surface of the comet.
The material burning off the comet by the solar collector creates a small jet of gas. The jet produces thrust, and over time, this pushes the comet away from its collision course. Scientists are developing solar collectors, but as yet, none are big enough to push a comet away from Earth. Every year, the Near-Earth Object Program finds hundreds of new bodies. The good news is none of them pose a threat to Earth in the next century. The bad news is comets are almost impossible to spot until it's too late.
The problem with detecting a comet is that they're very black, blacker than charcoal, so they don't begin to show their cometary form until they're inside the orbit of Jupiter, well inside the orbit of Jupiter, and that's just a few months from the orbit of the Earth.
Would Earth be ready to defend itself against a planet-killing comet in just 3 months? The answer so far is no. Yet the irony is that if it hadn't been for comets, there might not be life on Earth to defend. Over the last 20 years, missions like Giotto, Stardust, and Deep Impact have increased our understanding of the solar system and our place in it. But there are still so many questions left unanswered. How did our solar system begin? And what was there before? Is the Earth unique? Or are there other planets in other solar systems that could support life? And what is the fate of the Earth and the future of mankind? Scientists at the European Space Agency hope their latest mission, Rosetta, will provide those answers. The mission takes its name from the Rosetta Stone, a tablet found by the French in Egypt that allowed historians to decipher Egyptian hieroglyphics. The satellite is halfway through its 12-year, 4.4 billion-mile journey to Comet Churyumov-Gerasimenko. When it finally arrives in 2014, it will release a small probe onto its surface. The probe will stay on the comet for a week, taking photographs and performing a chemical analysis of the ice and dust, relaying the information back to the main body of the satellite. Rosetta is now millions of miles from home in the cold, dark recesses of space. Scientists anxiously await the outcome of its mission.
It's not just flying by, it's not just observing from a distance, it's like a geologist. A geologist doesn't go out into the field and just look at a rock. He takes out a hammer and looks at the inside, see how tough it is.
There are a few experiments, once they're proposed or the idea is out there, you go, why didn't I think of that? It's simple, but once we do it, the results will be profound.
And if Rosetta can land on a comet, could we one day mine them and use their resources to propel mankind deeper and deeper into space?
If we go into space and try and build habitats, we're going to need water. Comets have water. We're going to need rocket fuel, and if you break the water down into hydrogen and oxygen, that's the most efficient type of rocket fuel. So in the future, comets may be the watering holes and fueling stations for interplanetary exploration.
One day, we may need to leave Earth and go in search of a new home, because somewhere on the edge of our solar system is a vast comet that may smash into our planet and wipe mankind off the face of the Earth.
Perhaps the greatest question facing the human race is to discover where we came from and to find out what is our ultimate fate.
Every culture, every age has asked that question and tried to answer it.
It's one of the greatest adventures of the human mind to find out where we came from, where we are, and of course, in the end, where we're going.
Astronomy provides the basic information that each person needs to understand where he or she came from and where the human race is going.
Now, at the dawn of a new millennium, we are on the threshold of understanding how our universe began and how it will end. Cosmologists around the world are trying to unlock the origin and destiny of everything we see around us. One of this elite group is Bob Kirshner. He's on a journey to Cerro Tololo in Chile to measure if there's enough gravity to hold the universe together.
We've known for a long time that the universe is expanding and coasting along since the Big Bang. One of the questions has been how much gravity has been slowing down the expansion of the universe. Just like when you drive a car up a hill, you can slow down if you don't apply power because gravity's pulling back on you. We think that the expanding universe would be slowed down by the gravity, by all the stuff that's in the universe. One of the interesting things is that we've been able to do some work to try to measure that, and we found a surprising result. Not the one that we expected to find, but one that really turns the whole problem on its head.
Kirshner's team may have discovered answers that seal the fate of our universe. They've discovered that it's not just expanding, it's speeding up. Cosmologists now realize that to understand what the future may hold, they first have to unravel what happened at the beginning of the universe, at the start of time itself. In our daily lives, time is constant and dependable. It's almost impossible for us to imagine, but before the creation of the universe, there was no time.
We can trace back cosmic history to a stage when everything was very dense, very compressed, very hot. But the further we go back, conditions were so extreme that we can't really rely on any of our common sense intuitions. We can say that time, in the sense we understand it, didn't really exist before that.
So when did the clock start ticking? 12 billion years ago, there was absolutely nothing. No matter, no space, no time. We may never know how or why it happened, but a seething mass of energy smaller than an atom grew from nothing. You're inside the Big Bang, the birth of our universe, a violent fireball of unimaginable heat. For England's Astronomer Royal Martin Rees, understanding the Big Bang is the key to the universe.
Something that was literally originally only the size of a single atom or smaller expanded to be large enough to encompass everything in our present universe.
Only the minutest fraction of a second had passed. But all of this was puny compared to what was about to happen. Propelled by a new surge of internal energy, the universe suddenly entered an incredible period of inflation. It expanded 100 trillion times to the size of a grapefruit. Einstein's famous equation, E equals mc squared, told us that energy and mass were interchangeable. It gave us the knowledge to build weapons of mass destruction and the knowledge to understand how our universe was born. When a nuclear bomb explodes, a tiny amount of matter is completely annihilated and converted into energy. But in the Big Bang, the exact opposite happened. Pure energy was converted into matter. Approaching a millionth of a second old, the universe was brimming with energy, so intense that it was spontaneously converted into lumps of matter, and its arch-rival, antimatter. A titanic battle ensued. Subatomic particles annihilated each other, blow for blow, particle for particle. When matter and antimatter meet, they mutually destruct. This is the most powerful release of energy known.
If our universe started off with equal amounts of matter and antimatter, all the atoms would annihilate with anti-atoms, and we'd end up with a universe consisting just of heat and radiation, but nothing from which we and the stars could have been made.
But somewhere in this tiny blazing inferno, the process was slightly imperfect. There was more matter than antimatter. At the end of the battle, matter had won, and the universe was far from empty. Every time a particle of antimatter had been annihilated, the energy was converted into radiation. And that radiation is right before our very eyes. Don't adjust your set. Hidden in the interference on a badly tuned TV set is the energy signal left from the first second of the universe. The discovery of the Big Bang was one of the greatest scientific discoveries of all time, even though it was an accident. This is the horn antenna at the Bell Research Labs in New Jersey. Its unusual funnel shape was designed to collect faint radio waves from early communication satellites. It was being used for an entirely different experiment when it detected something truly remarkable, a discovery that would win 2 American scientists the Nobel Prize.
When I visit the horn antenna, I'm always reminded of the days back in the 60s when Arno and I were using it seriously. You know, it's amazing to think about, just doing your experiment and discovering the beginning of the universe. But there it is.
In 1964, Bob Wilson and his colleague Arno Penzias were using the horn antenna to search for natural radio emissions from our own galaxy. But as soon as they switched their giant earpiece on, it started humming. It was picking up weak but constant background interference. Wilson and Penzias had no idea where the signal was coming from. At first, they suspected nearby New York, but when they ruled that out, their suspicions turned on the local bird population.
There were a pair of pigeons living in the antenna. Once a week, we'd come up and disturb them. They'd fly away, but the next day when we were gone, they'd come back. So the inside of the horn was covered with white pigeon droppings. We got up in the horn reflector with a broom and swept it all out.
With the pigeons evicted, The two scientists were disappointed to find the interference was still there.
We looked in various directions. Sometimes we looked at specific objects, other times we looked at random parts of the sky, and every time we did that, we saw the same level, the same amount of excess noise, that it was the same in all directions.
They began to realize that it could have a more dramatic origin. What Wilson and Penzias had stumbled across was a background of microwave radiation, a faint afterglow of the battle that defeated antimatter 12 billion years before.
The microwave background comes from the initial very dense and hot stage of the universe. And as the universe expands, the radiation expands with it. And just like anything else that expands, it tends to cool off. It came from the early stages of the universe, and it's just out there. If you go outside, it'll hit you on the head. You won't notice it because it's so weak. It's at such a low level that it's almost undetectable.
Every television set on Earth can detect the radiation from the Big Bang. Antimatter had been defeated, and the universe was still only a second old. Over the next 3 minutes, the explosions created the kind of matter we would recognize today: hydrogen and helium. It was still too early for the universe to shine. In the dark ages that followed the Big Bang, these elements would combine together and provide the building blocks of the first generation of stars and galaxies. The atoms created 12 billion years ago are still with us today. Every time you take a sip of water, you're swallowing hydrogen atoms that were created at the very beginning of the universe. Most of the atoms in our bodies were created in the first moments of the Big Bang.
We tend to often dissociate ourselves from the universe. We tend to think of asking questions about it versus us. But of course, that's not really true. We're a part of the universe. And when we ask about the origin and evolution of the universe itself, we're really asking questions about the origin and evolution of ourselves.
Since the Big Bang, the universe has continued to grow and expand. To understand just how big it has grown, we need to take an imaginary spaceship ride from the Earth to the edge of the visible universe. Our nearest neighbor is the Moon, just 250,000 miles away. At the center of our solar system, 93 million miles away, is our Sun. After crossing the center of our solar system, we continue our flight beyond the orbit of the Earth. The next planet out is Mars. Beyond the orbit of Mars is the asteroid belt. A billion miles away is the giant outer planet Saturn, almost 1,000 times the size of Earth. As we leave the solar system, we would pass one of our earliest interplanetary explorers, Voyager 1, launched in 1977 and traveling at a mere 40,000 miles per hour. Proxima Centauri and Alpha Centauri, A and B, our nearest stars, are 25 million miles away. Our solar system sits in the quiet suburbs of a spiral galaxy, the Milky Way, a star city containing over 100 billion stars. Every star we can see in the night sky lies within our own galaxy. This is deep space. Out beyond the Milky Way, 10 million miles from Earth, is the next spiral galaxy, Andromeda. Even traveling at the speed of light, it would take 2 million years to reach here. Andromeda and the Milky Way form part of a small cluster of galaxies called the Local Group. But stretching out way beyond the Local Group are much greater clusters of galaxies. If it were possible to travel fast enough for long enough and reach the edge of the known universe, this is what we would see. Uneven clusters of galaxies, a pattern that was predetermined in the very first second of the Big Bang. This is as far as our spaceship can take us. We are now 50 billion trillion miles from Earth. This is where science ends and speculation begins. Astronomers may never see what lies beyond here. This is where the secrets of the universe are hidden. For centuries, astronomers have been trying to locate our exact position by looking further and further across the vast expanses of deep space. For 400 years since Galileo first pointed his telescope at the sky, astronomers have not only been looking across the far reaches of space, but back in time. Because the light from distant objects takes so long to reach us, every telescope is a time machine. Even traveling at an unbelievable 186,000 miles per second, light takes a long time to cross space. Light reflected off the surface of the moon is already over a second old by the time it reaches us on Earth. Look up at Saturn, and you're seeing it as it was 1.5 hours ago. And we see Andromeda as it was when the first humans walked the Earth. Its light has been traveling across space for over 2 million years. Here at the Lick Observatory, Sandra Faber spent her early career unraveling the mysteries of the most distant galaxies.
The biggest telescopes on Earth now are taking us back billions of years into the past, 90% of the way back to the beginning of the universe.
View light from the furthest visible galaxies, and you're seeing them as they were over 11 billion years ago.
A galaxy is really like a city of stars. Just as there are billions of people on Earth or millions of people in a city, there are hundreds of billions of stars in a typical galaxy.
The universe contains over 100 billion galaxies. Like giant hurricanes in space, their resident stars spin around a giant central core. To see into the heart of the most distant galaxies would require a very special telescope. In 1990, the launch of the Hubble Space Telescope promised astronomers a view of the early universe they had only dared dream of. High above the Earth's atmosphere, this billion-dollar looking glass would have a totally clear view of the most distant galaxies.
Like that, Houston.
But the dream turned into a nightmare. Soon after it was launched, they discovered that the mirror was misshapen. It saw everything out of focus. One of the repairmen sent up to fix the stricken telescope was astronaut Jeff Hoffman.
It was unbelievably embarrassing for NASA and for the astronomical community. I mean, I had astronomer friends who that summer when they were on holiday and people asked, well, you know, what do you do for a living? They didn't even want to say I'm an astronomer because the first thing everybody would say, oh, the Hubble telescope, ha ha, you know, it was a big joke.
First, the crew of the rescue mission had to capture the crippled telescope.
Hello, Jeff?
Then execute a repair mission unprecedented in the history of space flight. Spread over 5 days of spacewalks, they repaired the faulty optics. The replacement parts fitted perfectly. The problems came when Hoffman attempted to close the huge access doors.
Lo and behold, they did not close. And I worked, I went up to the top of the doors, I went to the bottom of the doors. But what we figured out was that we could use an extra tool which had a little strap and wrap that around some bolts to gradually winch the door close. We ended up spending over 8 hours outside, which is the second longest spacewalk that's ever been done.
At one point in the mission, they even had to dump a damaged solar panel overboard. With all the repairs completed, the cosmological community held its collective breath to see if the most expensive telescope ever built would finally deliver what its designers originally promised. This is what Hubble saw. The images they received were beyond anyone's wildest imagination. Free from the distortion of the Earth's atmosphere, images captured by the Space Telescope left even the most hardened of cosmologists in awe. Hubble captured the final moments of a star's life when it explodes and blows off layers of gas and dust. It also captured interstellar nurseries of newly born stars, each one as varied and unique as a human fingerprint. And dark pillars of cosmic dust more than 1 million miles long, ready to spawn a new generation of stars and planets. But Hubble's true moment of glory was still to come. The mission controllers pointed the telescope at a distant, empty patch of deep space and waited. Over a period of 10 days in 1995, emerging across the coldness of space, the Hubble Deep Field image revealed a tapestry of distant galaxies. This was the furthest back in space and time we had ever seen.
To point the telescope for hundreds of hours and let this light that has traveled for 10 billion years slowly dribble in and accumulate. When you see so far back and see so many galaxies and imagine that the sky is filled with them, billions of galaxies, that's like 10 galaxies for every person on Earth, something like 50 to 100 billion galaxies, and each one of them containing 50 to 100 billion stars, say. That's an enormous number of places where there might be planets and life and very interesting things going on in the universe.
Powerful computers have turned the real galaxies of the deep field image into a remarkable 3D journey to the edge of the universe. In the foreground are mature galaxies like our own. Further back in time are younger, energetic galaxies. But beyond here, the structures begin to thin out. This is as far as we can see. This is the edge of the visible universe, over 90% of the way back to the beginning of everything. Faint galaxies that were formed just 1 billion years after the Big Bang. Beyond these galaxies, we can see nothing. We're entering the universe's dark ages.
Sometime a few 100 million years after the Big Bang, this dark age must have ended when the first stars were born. And so the universe lit up for the first time, perhaps 500 million years after the Big Bang, and it's been lit by stars ever since.
The universe is so vast, some astronomers have decided to make a map of exactly where we are. Just as Galileo tried to make sense of our place in the heavens, here at Apache Point, New Mexico, a group of astronomers are trying to locate our position by constructing the biggest map that anyone has ever seen. Built specifically to map over 1 million galaxies, this is the home of the Sloan Sky Survey. Over a period of 5 years, astronomer Jim Gunn and his colleagues are about to start mapping our exact position in the universe.
We're in a galaxy, which is not a particularly remarkable galaxy, but this 3D picture that we will make of the nearby universe tells us how we fit into this vast scheme of things that is the universe, and I think will give us a much better idea of our place.
By systematically scanning the entire night sky from a site high above the desert floor, the results will be plotted not as a 2-dimensional route map, but a fully interactive 3-dimensional guide to the universe.
If you think about that from a kind of cinematic point of view, one could take this map very easily, put this map on a computer, and enable you to rotate the map, to fly through space, if you like, to look at our galaxy from outside, to look at the other galaxies around us from the other side, and take not only from any angle you want, but from any place in this map, and look out and see what it's like to be somewhere else in the universe than what we are, which is, of course, what you see in science fiction films all the time, but you will actually be able to do it with the galaxies that are there.
Jim Gunn's survey is an ambitious project, and it's only just beginning. This is how the final map may look. It's a computer simulation of superclusters of galaxies massed together in giant blobs. You are here. This would be the position of our planet, our solar system, and our own Milky Way. But on this scale, it would be impossible to see us or even any of our neighboring galaxies. This is a map of everything we can see. Everything in the universe, all the visible stars and galaxies, were born in the same furnace, the Big Bang. A ball of intense heat still cooling as it continues to expand. Cosmologists are not only confident that they have unearthed the universe's past, but that they can also predict its future. Space, like the surface of hot-blown glass, cools as it expands. Just as flecks of color embedded in the glass move further apart the more it stretches, so do the galaxies. Space is expanding in all directions at once. Modern cosmologists are now trying to measure if this expansion will continue forever. How will the universe end? The key to the future of the universe was discovered long before modern astronomers built their giant telescopes. Back in the 1660s, when Sir Isaac Newton had an encounter with a falling apple and discovered gravity. Newton formulated laws of physics which formed the basis of modern science.
He realized that the same force that takes an apple and pulls it down from a tree towards the Earth pulls the moon towards the Earth, and in fact pulls the Earth towards the sun and pulls the sun towards the center of our galaxy. But in fact, gravity is the weakest force in nature. If you wanted to show someone how weak gravity is, just take a friend to the top of a tall building and push them off. And it may take 12 stories for them to fall and gravity to accelerate them all the way down to the ground. But electricity and magnetism in a fraction of a second and a fraction of an inch will stop them. Because the reason you don't go through things is not that the atoms in your body hit the atoms in the table, but rather it's the electric fields between those atoms that stop you. So electricity and magnetism stops you in a fraction of a second, even though it takes gravity all that time to accelerate you.
Gravity may be the weakest force, but it's the force that holds the planets and the stars together. After Newton, perhaps the greatest scientist and mathematician of all time was Albert Einstein. Einstein had been an unremarkable student, and his first job was as a clerk in the local patent office. His general theory of relativity, announced in 1915, explained for the very first time how everything within the universe interacts: space, matter, even time. His calculations told him that the stars and galaxies should exert a gravitational pull on each other and should eventually collapse together in a catastrophic fireball. But they hadn't collapsed, so to make his equations work, he invented a special repulsive force. But it was a makeshift solution, and deep down, Einstein knew it. Then, a decade later, along came a man with the solution to Einstein's puzzle. Here, at the Mount Wilson Observatory in California, Edwin Hubble took the first steps towards forecasting the fate of our entire universe. Hubble was a World War I veteran and a brilliant lawyer. When he turned his renowned skills to astronomy, he came up with a remarkable discovery that would change the way we view the universe forever. He made the astronomical discovery of the century, that the universe was expanding. 75 years on, measuring the precise speed of that expansion is the job of astronomer Wendy Friedman.
What Hubble found was that almost all galaxies appear to be moving away from us. And this led to the idea that the universe is expanding. Here was evidence for the first time that the universe was actually in motion, that galaxies are moving apart. What that means is that you can essentially extrapolate backwards in time. It's like running a film in reverse. If galaxies are expanding now, then at some time in the past they must have been closer and closer together. And what that implies is that sometime early in the history of the universe, galaxies would have been much closer together. The matter in the universe would have been much denser and much hotter. And this gave rise to the idea of a Big Bang universe.
Hubble's revelation stood the astronomical community's understanding of the cosmos on its head. He'd used the same technique that police forces around the world use today to catch speeding motorists. Hubble used the astronomical equivalent of a police radar. Instead of using radar signals, Hubble measured the light that came from distant galaxies. He knew that their color would be slightly altered if they were traveling towards or away from us.
If an object is moving away from us, then the light from that object will be shifted toward the red part of the spectrum. If an object is coming towards us, the light will be shifted toward the blue part of the spectrum.
By determining just how much the color had been changed, Hubble could work out how fast a galaxy was traveling. It's an effect known as the Doppler shift, and it applies to both light and radar. Hubble found that all the light from all the galaxies was shifted towards the red part of the spectrum. They were traveling away from us at an incredible speed.
There have been dramatic improvements in the technology since Hubble's day, and we now have the advantage for the first time of being able to get outside of the Earth's atmosphere. That is, we can go to space, use the Hubble Space Telescope, named after Edwin Hubble, to measure distances to galaxies.
Modern astronomers have calculated that we, along with all the contents of our own galaxy, are traveling away from the nearest cluster of galaxies at 1,000,000 miles an hour. By the end of this program, the whole universe will have expanded 1 billion miles in all directions. Cosmologists need to find out if there's enough matter in the universe for gravity to stop it expanding and flying apart.
There isn't enough matter, normal matter, to account for all the matter we can weigh in the universe. We can actually weigh the galaxy the same way we weigh the sun and the Earth, using Newton's laws. We watch the sun go around the galaxy, and we use gravity to determine how heavy the galaxy really is. And when we do that, we find there's a lot more out there than meets the eye.
Wondering if there is enough matter in the universe to stop it expanding is a prime concern of Professor Stephen Hawking. Born 300 years after Newton, Hawking now holds Newton's old job at Cambridge University. Hawking already knows that the visible galaxies do not produce enough gravity. He now suspects that the universe is full of invisible dark matter.
If the universe continues to expand forever, everything will burn out and decay. The amount of matter we observe in stars and gas clouds is only about 10% of what is required to stop the expansion of the universe and cause it to collapse again. However, there might be other, dark matter, that we can't see, but which can still affect the expansion of the universe.
It just makes up so much matter, so much of the universe. It's at least 90% and probably 99%. If it wasn't for, we believe that dark matter is composed of elementary particles that arose in the Big Bang, and they're around us all the time and they're passing through us all the time. Once a day, you might get one interaction, in other words. The particle comes in, strikes an atom, it recoils, and it produces a little burst of light, ordinary visible light, which we can detect with our instruments and then amplify and record into our computers.
It will take years, but if their equipment successfully detects dark matter,
it could be that the universe will basically expand forever and simply dissipate, and eventually we'll end up with a, if you like, a soup of rather boring atoms and dark matter diffused around, and it'll be a sort of slow death and on into infinity, and that'll be it.
For some, the challenge of predicting the fate of our universe is compulsive. Their passion for cosmology often turns into a lifelong obsession.
There are a lot of people engaged in trying to find out what the universe is, and I think it's mostly the same kind of curiosity that kids have when they're 6 years old or 8 years old. It seems to get beaten out of them in school, but we're sort of the ones that, I don't know, the schools didn't affect or something like that. We're still asking those same questions and still trying to get answers to them.
Here at Cerro Tololo, cosmologists have made a startling new discovery. Bob Kirshner believes that dark matter may not be holding the universe together at all. They're forecasting how the universe will end by observing one of the most violent cosmic events, stars that explode in distant galaxies with unbelievable ferocity when they reach the end of their life. Supernovae. From the brightness of these explosions, Kirshner and his team can tell if a galaxy is near or far away. They measure the distant supernovae as markers to help them work out how fast the universe is expanding.
This is a very sensitive system that we're using. It has an electronic detector, and of course it's connected to a gigantic telescope. It lets you see objects which are about 100 million times fainter than you can see with your dark adapted eye.
Like Edwin Hubble, they're using the light from distant galaxies to get an accurate fix on the universe's rate of expansion. They thought they would be measuring how much the gravitational pull from dark matter was slowing the expansion rate down. But what they have found has stunned the cosmological community.
At the location. Well, maybe it's the other galaxy.
Rather than slowing down, the universe is speeding up. The galaxies are moving apart faster than ever before. Dark matter is not powerful enough.
See, but it looks to me like there's still something there at the location that was there, right there. Oh, yep.
Scientists now believe that the universe will not collapse in a catastrophic fireball, nor will it coast on serenely. Instead, its contents will speed apart faster and faster until lost in the vast blackness of space.
So if the picture that is coming from the supernovae is really right, the universe will expand forever. In fact, faster and faster on into the future. Now, this is really not anything to worry about, even though it is a kind of a bleak future of an empty, cold, dark universe.
What Kirshner may have discovered is a remnant of the original Big Bang. The inflation that started in the very first second of the universe is taking off again.
What makes cosmology at the end of the 20th century so exciting is that, in fact, we understand that the largest things in the universe are really determined by the smallest things in the universe, that there's this connection, because at the very early Big Bang, the fundamental forces governing the microscopic structure of matter really determined the structures we see today on scales as large as galaxies and superclusters.
The shape of our universe, everything we see around us, was determined when the universe was smaller than an atom and only a fraction of a second old. Our universe is cooling and dying. In 1 billion years from now, our first unmanned spacecraft like Voyager 1 will leave the Milky Way and drift unhindered through the universe. As the universe reaches middle age, even the longest-lived stars will start to burn out.
Our sun has about 5 billion years of life left, and very few stars will still be shining 10 billion years from now. The dead stars will still orbit around the center of the galaxy, but near collisions will gradually cause most of them to fall into a giant black hole at the center.
Suppose we look ahead to when the universe is 100 billion years old. Then it would be a rather dull and dark place, because all but the faintest and most slow-burning stars will have died, so the universe will not only disperse, but all the galaxies will get fainter.
As the universe expands with age, gravity will lose its precarious grip. If you could be there to witness it, you would see absolutely nothing. Is there anything the human race could do to flee from such a dark fate? Could we escape into another dimension, into another universe?
The best ideas that people have come up with do suggest that maybe our Big Bang was not the only one, and that the inflation which led to our universe may have happened elsewhere, maybe an infinite number of times, in some grand eternal cosmos.
If other universes do exist, could we ever find a way of traveling into one?
It's incredibly interesting that there's a lot more we don't know about the universe than we do, in spite of all we've learned up to date. And therefore, some of the wild ideas from science fiction, including things like even wormholes, might or might not be possible. We just don't know at this point.
Wormholes are another prediction of Einstein's theories. Here, space is so twisted that it forms a tunnel from one universe to another. Even if these hypothetical holes in space and time do exist, entering a neighboring universe could be unwise. Travel into one where the laws of physics are even slightly different from our own, and you'd cease to exist at all.
Even though we have very small brains and we lead very brief lives and so on, the fact is we're able to understand where we are, and because we can use instruments like the big telescopes, the physics that we learn on the surface of the Earth, and the ideas that people have had over the last few centuries to build up a coherent picture. And I think we should be proud of that. We've done pretty well.
I feel it's been a great privilege and a huge amount of luck to be present to witness an important science like cosmology hit its peak.
In some way, creatures like us, and there probably are many, are the consciousness or the intelligence of the universe. It's almost as if the universe invented a way to know itself.
After centuries of gazing at the heavens, scientists now know that everything in our universe was born 12 billion years ago. Before the Big Bang, there was nothing. This violent explosion gave birth to everything we can see. Countless galaxies, stars and planets, even life itself. We have blasted men and machines to our neighboring worlds, sent probes to the outer solar system, discovered volcanoes erupting on the surface of distant moons, visited worlds more diverse than we had ever imagined.
What pushes us to want to explore planets is a need to know. And the planets now, and for the last nearly 40 years, have been within our reach.
We have landed on Mars, walked on the moon. At the dawn of a new millennium, we're at the start of a new era of exploring the planets. $12 billion years ago, our universe was forged in the Big Bang. It created countless galaxies, the birthplace of stars and planets. Our own star, the Sun, and its system of 9 orbiting planets, was born over 7 billion years after the Big Bang. This man is about to take a trip into the depths of our solar system. Without even leaving the Earth's atmosphere, planetary astronomer Richard Terrell is on a journey to explore the origin of our planets. He's come here to the heart of the Mojave Desert, one of the driest and most barren places on Earth, to search for meteorites, rocks from outer space.
Meteorites are phenomenally important because they're really the only samples we have of what's out there, except for the moon rocks that we've collected. They're objects we can place in our laboratories. They can tell us what the raw ingredients were that formed the Earth and the planets.
Space is not as empty as we think. Each day, the Earth sweeps up over 20 tons of space debris. These are shooting stars, small lumps of rock captured by light-sensitive cameras as they burn up in the Earth's atmosphere. Usually, large meteorites break into many smaller fragments. They can land anywhere on Earth, but it's only when they land on an ice cap or a desert that we can find them. Meteorites are the builder's rubble from the greatest construction site of all time. They're fragments left over from when the planets were born.
The meteorites really tell a fantastic story. Most of the meteorites are incredibly old, dating back to the origin of the Earth and the Sun. They're really telling us the entire chemical and organic history of the material that formed the planets and give us a great deal of insight into our origins and the origin of life.
By radioactive dating of the minerals in these rocks, astronomers have been able to work out that the Earth and all the other planets were created 4.5 billion years ago. The solar system started life as interstellar gas and dust, a giant disk spinning inside the Milky Way. As gravity pulled the fine grains of dust together, a disk hundreds of billions of miles wide began to spin and collapse. At its heart, the material was so dense, nuclear fires ignited our sun. The heat of the new sun blew the lighter gases away to the edge of the disk, where it condensed to form the outer giant planets. At the center were small, heavy planets rich in iron. These new, young protoplanets were bombarded by the debris.
In the inner solar system, where we have 4 planets today, there were between 50 and 100 protoplanets, young planets, that ranged in size from about moon size to Mars size.
Our own planet was about to experience a traumatic birth. It lay directly in the path of another protoplanet.
This is a body that's comparable in size to the Earth, so it would not be as if there was a small object in the sky. As it got close, it would literally fill the entire sky.
There was no escape. A collision was inevitable.
If this impact were to happen today, there would be no place to hide. This is truly a cataclysmic event.
The impact energy was so enormous, both protoplanets were melted. The liquid cooled, and the Earth was reborn. Orbiting around it was another new, smaller world, our moon. It gave us a target we could reach, a possible stepping stone from which to explore further into deep space. Without the proximity of our nearest neighbor, we may never have started to explore space. In 1961, President Kennedy used the moon to set the greatest challenge in history.
I believe that this nation should commit itself to achieving the goal, before this decade is out, of landing a man on the moon and returning him safely to the Earth.
Even the astronauts of Apollo 11 believed there was only a 50-50 chance they would return safely from the moon.
We choose to go to the moon. We choose to go to the moon and do the other things, not because they are easy, but because they are hard.
To reach the moon, NASA created the most powerful rocket they'd ever built, the mighty Saturn V.
Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running.
The world held its collective breath as the three men set out on the most daring adventure of all time.
Houston, Apollo 11 and Saturn gave us a magnificent ride. Roger, 11, we'll pass that on, and it certainly looks like you're well on your way now.
The astronauts traveled 240,000 miles in 4 days. From their tiny windows, they looked out on a world pockmarked by millions of impact craters.
You're go for landing, over. Roger, understand, go for landing.
To avoid landing on rough ground, they aimed for a large flat plateau, known to generations of astronomers as the Sea of Tranquility.
Okay, engine stop. We copy it down, Eagle. Houston, Tranquility Base here. The Eagle has landed. That's one small step for man, one giant leap for mankind.
The date was July the 20th, 1969. Man had taken his first step towards the planets. Over the next 3 years, 5 more Apollo missions landed on the surface of the moon. Only 12 men have walked there. The last man to stand on the moon was the commander of Apollo 17, Gene Cernan.
That's beautiful. This has got to be one of the most proud moments of my life, I guarantee you.
Just the fact that you are there. You are on another body in our universe that is different, distinctly different, separate from our Earth, makes it overpowering. You know, here I am where no man has ever been before. Nobody has ever walked where I'm walking. No one has ever seen the mountains and the valleys and the boulders that I've seen. That makes it beautiful. That makes it special.
The lunar surface is covered in fine powder. It's the legacy of billions of years of pulverizing impacts. Beneath the powder, most of the crust is made of ancient rocks formed when an ocean of liquid magma cooled over 4 billion years ago.
Because the bottom of the core is not smooth, it's very jaggedy and fragmental-like. 9, proceeded, 3, 2, 1, ignition. Right away, Houston. Vector grid. Back off.
Apollo had cost America $24 billion. The American public was tired of paying for expensive manned flights.
We were the last mission of Apollo, and I knew that I'd be the last man to have left my footprints on the surface of the moon. But I never believed, ever, that I'd be standing here over a quarter century later and still be the last man to have walked on the surface of the moon. I think in one sense it tells us what we have not done over the last 25 years as much as it tells us what we have done.
Four days after leaving the moon, Apollo 17 safely re-entered the Earth's atmosphere. This was the end of the Apollo program, the end of an era. Over a quarter of a century after the last astronaut left the moon, NASA launched an unmanned probe. In 1998, the Lunar Prospector probe was sent to detect any resources that might be useful if we ever wanted to return to the moon and build a permanent base. One of its tasks was to search for water by sniffing for hydrogen particles from a height of up to 100 miles above the lunar surface. Lunar Prospector spent 9 months orbiting the moon, scanning every square inch. Its search was not in vain. As it flew over the poles, it detected hydrogen atoms, probably from water frozen below the surface. Lunar Prospector had found a resource that could revolutionize space travel.
Ice is important because you can break ice into its component pieces. You can make ice into hydrogen and oxygen. And hydrogen and oxygen are the primary components of rocket fuel.
Most rockets are powered by liquid hydrogen and liquid oxygen. If we could mine ice from the lunar surface, we could turn it into rocket fuel and use the moon as a launch pad towards the planet.
If you would have the materials that you need in space already in space, you've saved a lot of money. So that makes the 10 billion tons of water worth trillions and trillions of dollars. And nations have gone to war for a lot less.
Lunar astronauts of the future could be mining engineers. The water ice that Lunar Prospector detected is most likely frozen underground in craters near the poles that lie in permanent darkness.
It allows you to use the moon as a filling station. You can stop at the moon, you can use the ice to make hydrogen and oxygen and refuel your rocket and basically go anywhere you want.
With this bonanza of cheap fuel, our descendants will be free to roam the solar system and search for the next planet that we might call home. At the end of its successful mission, Lunar Prospector was sent crashing into the lunar surface. When it struck, it was traveling at almost 4,000 miles an hour. The solar system is vast. There are 9 known planets. The giant outer planets orbit billions of miles out from the sun. The human race has evolved by taking risks, conquering new environments. But sending astronauts out here will take generations. The only way we can visit these planets in our lifetime is by sending robotic probes. Inside the asteroid belt are the 4 rocky terrestrial planets: Mars, our home, Earth, and inward towards the sun are just 2 planets we could try and visit: Venus and Mercury. Mercury orbits just 36 million miles from the Sun. Inside, it's made of 70% iron, far more dense than the Earth or the Moon. In 1973, NASA sent Mariner 10 to photograph the surface of this harsh and remote world. The pictures it sent back revealed that, like the Moon, its surface was heavily cratered, battered by asteroid and meteorite impacts over billions of years. With virtually no atmosphere to protect its surface, Mercury bakes at over 400 degrees Celsius in the day and freezes at minus 183 at night. Venus proved even more inhospitable. In the 60s and 70s, both the Soviet Union and America raced to find out what was hidden below the thick layer of clouds. Armored like a tank, the Soviet Venera 9 survived the descent through the sulfuric acid clouds just long enough to transmit a picture of its base sitting on the scorched rocky surface. In the 80s and 90s, orbiting spacecraft used radar to penetrate the acid clouds and map the surface in detail. Without even setting foot on the planet, scientists had seen a landscape beyond their wildest imagination. Its surface is littered with volcanic cones and lava flows. The temperature on the surface of Venus is hot enough to melt lead. The atmospheric pressure is so great it would crush a tin can. It's unlikely that we would ever want to set foot here. It may be well into the 21st century before we can visit even the more hospitable of the planets. For most planetary scientists, the best method of trying to understand what conditions are like on the surface of other planets is to compare them with the similar terrain here on Earth. Our planet is peppered with volcanic structures, features that can help to unravel the mysteries of distant worlds. For John Spencer from the Lowell Observatory in Flagstaff, Arizona, this flight over his local volcanic lava field is like flying over Venus or Mars.
We're now looking at another absolutely gorgeous example of a cinder cone and a lava flow. You can see the crater in the center and the big pile of cinders around the outside, and then coming out here at the base and spreading out for several miles is a thick lava flow going to other planets where all we can really see is the shape. We can't go down on the surface and sample the rock. We can still tell what the composition of the volcanoes is and something about their history just by looking at their shapes.
This group of recently active volcanoes in northern Arizona has spewed dark basaltic lavas from beneath the Earth's crust onto the surface.
Seeing lava flows coming away from craters like this is a surefire sign that we're looking at volcanic activity, whether we see it here on the Earth or whether we're seeing it elsewhere in the solar system.
Volcanoes help create the oceans and our atmosphere. If we can find volcanic structures like this on Mars, we can speculate that once it may have looked more like Earth. When the first spacecraft flew past Mars, the evidence for volcanic activity was unequivocal. Images beamed back revealed structures very similar to those the scientists could see on Earth. These cones are thought to be dead now, but the evidence of an active past is everywhere. Mars boasts the largest volcanoes in the solar system. This is Valles Marineris, the largest rift in the solar system. If it were here on Earth, it would stretch across the Atlantic. It's a giant scar, evidence of a dynamic past when the Martian crust was torn apart. This is the Jet Propulsion Laboratory at Pasadena, California, home of NASA's unmanned space missions. The task of getting the first mobile rover to land safely onto the surface of Mars was the responsibility of JPL's Rob Manning. Manning and his colleagues had spent years designing and building a new robotic rover called Sojourner. It would be the first vehicle that NASA had landed on another planet for over 2 decades.
Going to Mars for the first time in 20 years was a challenge because a lot of the people who knew how to go to Mars and land on Mars were dead or retired. So we had to go back to the drawing boards and really figure out, again, from first principles, how to bring a lander to another planet.
Manning's young team decided on a radical new way to land. To save money, Sojourner would be dropped down onto Mars inside inflatable airbags.
Main engine start. 1-0 and liftoff of the Delta rocket with Mars Pathfinder. And the vehicle has cleared the tower.
After a 7-month flight, the Pathfinder mission made its final approach. Manning and his team were about to discover if their unique method of landing would work.
The next event is lander separation. That should occur in about 5 seconds.
Sojourner rocketed down through the thin Martian atmosphere and survived at least 15 bone-jarring bounces. Sojourner had come to a stop precisely on target. Years of hard work had paid off. For Manning, it was a moment of pure ecstasy. For the first time in a generation, NASA had returned to Mars.
Once the pedals opened up, and the next day, when we finally got Sojourner to stand up and roll down the ramps, for the first time, we had a mobile robot, a mobile laboratory, a mobile geologist that go out and explore another planet.
For the men and women who drove Sojourner from tens of millions of miles away, this was the next best thing to being there.
Operating your rover and lander on another planet, it feels like an extension of yourself. You really feel that you are there. Every day when we came to work, we went to Mars and we saw it for ourselves. It felt like an extension of our hands and eyes. And so it was very exciting. We knew what that landing site felt like to be there.
The Pathfinder mission had landed Sojourner in an area thought to be an ancient floodplain. As it roamed the surface for 84 days, it examined the boulders and discovered that Mars was covered with many different types of volcanic rocks. In 2003, NASA plans one of their most spectacular of all missions. This flight will happen exactly 100 years after the Wright brothers flew their first plane on Earth. The Mars airplane will fly to the most inaccessible regions where life might have existed and photograph them from the air. But for some people, robotic explorers aren't enough. They believe that true exploration can only be made by humans.
Have you ever seen a robot have a ticker tape parade in New York City? No. That's the big difference. We must go. It's within us to go. The question we ask about what is it like, what does it feel like, what does it look like, are questions people can relate to only through a human being, not through a robot, not through a camera, not through a computer chip.
As early as 2020, there might be a manned mission to Mars, the first to carry humans to another planet. Traveling to Mars will be a huge risk. It will take 9 months just to fly there, a round trip of at least a year and a half.
We will settle Mars, we will live there, it's a sister planet, it's there, it's beckoning our call, and we will inhabit it very much like we inhabit the Earth. And I can't tell you why or how quickly. People are going to say, what about water, what about, it's all there. All we've got to do is go find it and make it happen.
Carolyn Porco is a planetary scientist whose professional career has coincided with the modern era of planetary exploration. She's devoted her life to the giant outer planets that lie beyond Mars.
No matter how you cut it, the vast majority of our solar system exists out beyond the orbits of the asteroids. Inside, you have 4 measly little terrestrial planets, Mercury, Venus, Earth, and Mars. And while they're very important to us, especially the third one, most of the solar system is way beyond us.
In 1977, 2 identical Voyager spacecraft were launched to Jupiter on a path that would then catapult them onto Saturn. It was a now or never opportunity that took advantage of an alignment of the outer planets that only happens once every 176 years. Voyager 1 was spun out of the plane of the solar system, but Voyager 2 was flung on towards Uranus and Neptune. Voyager 2 sailed past Uranus at 40,000 miles per hour. It made its final rendezvous with Neptune after traveling over 4 billion miles. The Voyager spacecraft were the most sophisticated machines of their time. Their cameras would electronically record pictures, and their large white dishes beamed them back. The scientists knew that one day their spacecraft would fly beyond the solar system. They were keen to include a message for any curious aliens. Gold-plated LPs with greetings from every nation on Earth were bolted onto the spacecraft. They came complete with instructions and a stylus.
As the Secretary General of the United Nations, an organization of 147 member states, I send greetings on behalf of the people of our planet.
Silema Gemen, Oitines Podeste Chairete.
Paz e felicidade a todos.
各位好嘛，祝各位平安健康快樂。
Adanish Lushulmu.
ขอส่งมิตรจิตมาถึงท่านทุกคน
Hello from the children of planet Earth.
2 years after launch, Voyager approached Jupiter. It recorded this remarkable time-lapse image of the king of the planets spinning on its axis. Hard to believe that this giant gas bag could swallow more than 1,300 Earths. Jupiter's 4 largest moons, Ganymede, Callisto, Europa, and Io, were clearly visible as they orbited the planet. Here, circling the largest planet, was an entire planetary system in miniature.
I was one of those people standing in front of the monitors watching these images come down for the first time. Things we had never ever seen. People were lost for words. Very intelligent, bright people who'd studied planets their whole lives were lost for words. You know, I had the impression of being on the bow of a ship and, you know, entering uncharted territories and discovering things that no human had ever seen before.
Strangest of all were Jupiter's cloud tops. Here in intricate detail was the fearsome beauty of the Great Red Spot, a hurricane twice the size of the Earth, for some unfathomable reason has been raging for more than 300 years. Jupiter spins so fast that with a day less than 10 hours long, its clouds are drawn into streaks around the planet. Unlike Earth, its multicolored clouds are not powered by the sun. These storms of liquid marble are fueled by heat inside the planet. A childhood fascination with the king of the planets set amateur astronomer David Levy on a path that would help him discover a comet and predict Jupiter's most dangerous moment.
Well, I've been fascinated with Jupiter since the summer of 1960. That summer, I had my first telescope, and with my parents, I went outside, set it up, and looked up at the sky and saw the brightest star in the whole sky. Had 4 little moons and little bands across it, and I said, "Hey, that's Jupiter." It's the first thing I ever looked at through a telescope. And I think if that particular night, if my dad had said, you know, in 35 years from now, a comet with your name on it is going to go smashing into that planet, I would have been pretty surprised.
In 1993, David Levy helped discover an icy juggernaut that had roamed the back streets of the solar system for over 4 billion years. But Comet Shoemaker Levy No. 9 hadn't reckoned on the mighty gravitational power of Jupiter. The broken fragments were being sucked in by the largest planet in the solar system. Like bombers in formation, Shoemaker Levy 9 made its final approach. The fragments plummeted down through the endless atmosphere. On the 16th of July, 1994, the astronomers back on Earth watched the mighty flare as the first fragments smashed into Jupiter. The titanic collisions left a series of massive scars across the planet.
Jupiter is the solar system's vacuum cleaner. If Jupiter weren't there, those comets would still be running around, smashing into all of the inner planets, including the Earth. The Earth would be being hit by comets instead of once every 100,000 years, might be being hit every 100 years or every 1,000 years. And we couldn't be here. We couldn't live on an Earth that was being smashed by a comet every 1,000 years.
But it was Jupiter's moons that held the greatest surprise. When Voyager turned its cameras on the innermost moon, Io, it revealed the most active and dynamic body in our solar system.
At the time of the Voyager flybys of Io back in 1979, we got our first close-up pictures of Io from the spacecraft as it flew past. And one of the engineers saw these sort of weird clouds and were not at all able to figure out what this was, but eventually decided that this had to be something real. It had to be volcanoes that were blasting material off of Io.
For Earth-bound scientists like John Spencer, one way to interpret what the volcanoes on Io are made of is to compare them to similar volcanic structures we can see here on Earth. These fresh lavas are made of basalt. The shape of these flows bear an uncanny resemblance to features that Spencer has studied on the surface of Io. Since Voyager, later missions have photographed this festering world in even greater detail. Spencer believes that the volcanoes of Io seem to have erupted the same black lava we can find on Earth. Io is only the size of Earth's moon, yet its largest volcanoes are hundreds of miles across. Because of the low gravity, they spew lava hundreds of miles above Io's surface. Io's close proximity to its parent planet Jupiter exacts a heavy price. As Io orbits around, it's stretched and squeezed by the immense gravitational forces.
The reason there are volcanoes on Io is because Io is very close to Jupiter and it's distorted quite a lot by Jupiter's gravitational field. Sometimes it's closer to Jupiter, sometimes it's further away. And when it's closer, it's stretched out, and when it's further away, it relaxes. So continually, once every orbit, Io is being squeezed and deformed, and that just puts a lot of heat in the interior. And that heats up the interior to the point where you have volcanoes on the surface.
As Voyager left Io, it captured real moving images of the first active volcanoes we had ever seen beyond the Earth. Voyager's next port of call was Saturn. It had taken the two probes over 3 years to reach here. Even from Earth, the rings are clearly visible, but Voyager discovered that they were wafer thin. They're composed of millions of separate rings, each made of countless fragments of rock and ice. Above them hover strange dark shadows, thought to be grains of dust swarming in Saturn's powerful electromagnetic fields. Slightly smaller than Jupiter, Saturn is still 750 times bigger than Earth. And like Jupiter, it's orbited by its own mini-planetary system of moons. Mimas, Rhea, Dione, with a count of over 18 moons, Saturn has the most moons of all the planets. The Voyagers were only able to spend a few precious hours photographing Saturn and its moons in detail. Carolyn Porco and her colleagues recently videoed their last farewell to a new probe to Saturn, Cassini. They had spent years designing a machine that will spend the rest of its life endlessly orbiting and photographing Saturn.
Cassini will be, once it pulls into orbit around Saturn, will be the farthest outpost that humans have ever dispatched in the solar system. And it will be the closest look at what still is for us a very exotic environment.
6, 5, 4, 3, 2, 1, and liftoff of the Cassini spacecraft on a billion-mile trek to Saturn. We have cleared the tower. Pitch program is in. Roll program is in.
To see Cassini, this spacecraft that many of us had spent 7 years of our lives working on, designing and building, to see it get launched atop this gleaming white rocket, which rose from the launch pad, and it made this beautiful sweeping arc across the eastern sky, and then it was gone. I mean, it was literally gone. It left the Earth.
Stand by for solid rocket booster separation at 2 minutes. And the Cassini spacecraft is on its way to Saturn.
Named after the 17th century astronomer who first discovered a gap in Saturn's rings, the Cassini probe will arrive in July 2004. Cassini will also visit the largest of Saturn's moons, Titan. This orange orb is wrapped in a thick atmosphere. What lies below is anyone's guess. But there are tantalizing hints its surface may be covered with oceans of methane, crammed with the building blocks of life. Cassini will target and release the Huygens probe towards Titan. This probe is built to withstand landing on either an ocean or solid land. It will transmit back any signs of organic molecules from this unknown world. Voyager 2 reached Uranus early in 1986. It was 9 years since it had left the Earth. Uranus is colored blue because its atmosphere contains traces of methane. It's a featureless, cold world, but Uranus is different from all the rest. It rolls around the sun, spinning on its side, possibly because of a giant impact in its early life. Uranus is encircled by at least 11 incredibly thin rings of ice and dust, which Voyager showed us clearly for the first time. Last of the gas giants was Neptune, a giant blue sphere 2.8 billion miles from Earth. It was August 1989. Voyager had taken 12 years to reach here. It's so far out that it takes Neptune 165 years to orbit the Sun. It was remarkable that Voyager could photograph Neptune at all. Out here, the sunlight is only 1,000th as strong as it is on Earth. Like Jupiter, there is no solid surface. It's all gas, covered in layers of storm clouds. These are the fiercest storms in the solar system. The winds blow across the surface of Neptune at 1,400 miles an hour. Voyager's final task was to visit Neptune's largest moon, Triton. Across its surface were a field of ice volcanoes, where dark frozen nitrogen had spewed out onto the surface from underground. Our solar system had saved up its most bizarre object till last. Its task completed, Voyager left Neptune behind, hanging in cold, dark, empty space. It wasn't until the launch of the Hubble Space Telescope, above the Earth's atmosphere, that we could get a clear view of the furthest planet in our solar system. Hubble gave us our first view of this icy planet and its moon, Charon. Pluto is officially the 9th and last planet of our solar system. But recent research suggests that it might not be a true planet at all, but one of hundreds of thousands of icy worlds orbiting in a belt beyond the edge of the solar system. Pluto and its numerous cousins form a belt of debris that are the leftovers from the birth of our solar system 4.5 billion years ago. Planetary astronomer Richard Terrell decided that if he could find similar large disks of debris orbiting around distant stars, it might provide evidence that other planets were being created inside our galaxy. At the Canada-France Hawaii telescope on the summit of Mauna Kea in Hawaii, Tyrrell is successfully searching for new planetary systems orbiting around stars similar to our own sun.
We're now finding morphology, very, very exciting structure within these disks. We're seeing rings, we're seeing cleared out gaps. All of these are real indicators that these disks not only are associated with planetary formation, but may even signal to us that planets have formed around these other stars.
After more than a decade of searching, Tyrrell has now discovered 6 disks orbiting around new, young stars. For the first time, even the skeptics realize that our galaxy may be teeming with other solar systems, full of planets just like our own.
Most young stars will have these disks, which probably means that most stars have gone through the process which could lead, or probably leads, to planet formation. This is a tremendously important idea and leads to the conclusion that perhaps the majority of stars we see in the night sky, the majority of stars in our galaxy, contain planets.
The opportunities for discovering new planets will be endless. Future generations will be able to travel beyond the edge of our solar system and conquer billions of new worlds.
As we discover more planets around more suns and other galaxies somewhere out there in space, it's inevitable, as much so as me walking on a moon, that we will someday walk on those other planets.
Well, I think as human beings, we're always looking to explore the next horizon. And now that we've explored our planet, now we look up to the sky.
I know there are tremendous engineering challenges, and it won't be in my lifetime or, our children's lifetime, but eventually we will do it because we are designed to explore.
Quite literally, there are more stars in our universe than there are grains of sand on every beach on Earth. If you run your fingers through the sands on the beach and try to imagine just one of them being painted blue to represent the Earth and life on Earth, you'd have to be insane to think we're the only ones here.